Assalamualaikum and hi everyone. I am Nurhanani binti Muhammad Hashim and my metric number is 156097. So in this video, we're gonna learn about the recent technologies in spectroscopy due to its instrumentation and its application. So the UV-VIS-NIR Spectroscopy is an effective analytical technique to determine the optical properties of liquid or solid samples, including the transmittant, reflectance, and absorbent, and it can be used to characterize the semiconductor, coating glass, and more. So the UV-VIS-NIR Spectrophotometer UV3600 Plus has been designed by Shimadzu due to its higher sensitivity. So we're gonna learn the visual aids, the operating principle, its advantages, and there are two applications that we're going to share to you, which is the commercial mineral water sample and the quantitation mineral water sample by using the multiple linear regression, and the second one is the metamaterial based sucrose detection sensor. Next, we are moving on to the description of instrument. So basically, this spectrophotometer have three detectors, which is for the UV-VIS region, we have the photo multiplier tube PMT, and for the NIR region, we have two, which is indium gallium arsenide in GaAs and the PBS detector lead sulfide. And it is used to ensure the high sensitivity over the measurement wavelength, and the gap between is typically low.
Hi, my name is Nurafifa binti Muhammad Kamal and my metric number is 159044. What do you guys think? Isn't it impressive? So what is the operating principle of this UV-VIS-NIR spectrophotometer? Firstly is the measuring of light absorption. In this UV-VIS-NIR spectrophotometer, and the light concentration and the optical properties of the sample will determined by measuring light absorption according to ultraviolet, visible, and near-infrared light wavelength. Secondly, it follows the Beer-Lambert law, where the concentration of a compound can be determined from the light absorbed at a specific wavelength. Moving on, we will look into the measurement range, accuracy, and unique capabilities of this UV-VIS-NIR spectrophotometer. This model we choose is capable to achieve highest resolution of ultra-low stray light with high-performance double monochromator, with a measurement range of 185 to 3300 nanometer. Measurement become possible over a wide range including ultraviolet, visible, and near-infrared, thus allow wide variety of spectroscopic analysis. Then moving to the accuracy, it is promising with high accuracy of absolute reflectance measurement with ASR series attached to it. This model is designed with some unique capabilities. It has a wide range of accessories such as the multi-purpose large sample compartment with integrating sphere and 3 detectors that enable to measure light, solid, and even powder. And lastly, it has temperature control cell holders as well as micro cell holders.
Assalamualaikum, my name is Siti Nashamira binti Aspu. My metric number is 158137. I will explain about the advantages of this instrument. One of it is high sensitivity. The UV3600 employs 3 detectors to cover a range from UV to NIR, giving users the ability to handle measurement with extremely exact transmittance and reflectance. So this means we can get super accurate readings of how much light passes through or reflect of a sample. Next is high performance. With its high performance grating double monochromator, the UV3600 achieves great resolution at a low stray light level. In simple terms, it gives us fantastic clarity and detail in our measurement. Next is optional accessories and software. Numerous extra accessories such as integrated sphere attachment and a sizable multi-functional sample storage are compatible with the UV3600. It also equipped with the UV probe software suite. This software is like the brain behind the brain, making it easy for us to operate the spectrophotometer and analyze the data we collect.
My name is Sarah Nabila binti Muhammad Suhaidi. My metric number 158314. For the application, the first application is UV and NIR spectra of commercial mineral water samples and quantitation mineral water sample mixtures by multiple linear regression. For this application, we are using the UV-VIS-NIR Spectrophotometer. By using this UV-VIS-NIR Spectrophotometer, the absorption spectra of 4 commercial mineral water samples A, B, C, and D from various natural water sources were measured in the UV area from 190 to 250 nanometer. For the Table 1 are the list of the measurement parameters that are used. The measurement parameters that are listed are measurement wavelength range, scan speed, sampling pitch, photometric value, and also slit width. And the figure 2 is show the spectra of 4 mineral water samples in A, B, C, and D. The identical samples absorption spectra were then analyzed in the near-infrared range of 1000 to 18,000 nanometer. Every sample was measured with air serving as the reference, and each sample was filled with a 2 mm quartz cell. Next, the water absorption peak in Figure 3 near 1450 nanometer is magnified in Figure 4. Figure 3 shows the NIR spectra of 4 mineral water samples measured with a 2 mm quartz cell, and for the Figure 4, it shows the magnified region of Figure 3 spectrum. So, we can see that in Figure 3, there is a peak of water absorption near 1450 nanometer, and then it is magnified to Figure 4, and there is no peak like Figure 3. And for the Table 2 lists the measurement of parameters that are employed. The Table 2 is same as the Table 1 just now, and the measurement parameters are all the same. It is evident that there are very few differences in the mineral water samples absorption spectra in the near-infrared range. Next, for the quantitation of mixed mineral water samples by multiple linear regression. For this quantitation, different ratios of A, B, C were used to generate mixed samples, and also mixing ratios were found by utilizing the multiple linear regression on the collected absorbance data. So the UV absorption spectra of 9 standard samples with various mixing ratios and 3 verification samples with non-mixture ratios for verification were generated. Table 3 and Table 4 list the mixture ratios of samples verification. Table 3 shows the mixture ratios of standard samples, while Table 4 shows the mixture ratios of samples for verification. The measuring parameters match those stated in Table 1 on the preceding page. So, for the wavelength, we use 4 wavelengths: 200 nanometer, 205 nanometer, 210 nanometer, and 215 nanometer. Each constituent has a calibration model made for it using the regression analysis function. Table 5 lists the multiple linear regression equations for 3 models: water model A, water model B, and water model C. Lastly, the mixture ratios of the elements corresponding to each model are computed by substituting the absorbance values for the verification samples at 4 wavelengths in the various regression equations that are produced. Table 6 shows the quantitation results for verification samples for each water: A water, B water, and also C water, and for each verification sample. And the result shows the positive results. For the case study 1, it is related to application 1. This study related to mineral water samples in order to observe the analysis of different water samples by using Shimadzu UV-3600 plus UV-VIS-NIR. This Shimadzu UV-3600 plus UV-VIS-NIR can observe for every sample with air serving as the reference, and each sample was filled with a 2 mm quartz cell. Thirdly, the parameters that can be used in UV-VIS-NIR and also the application 1 are measurement wavelength range, scan speed, sampling pitch, photometric value, and also slit width. Lastly, for the quantitation mixed mineral water sample, the UV absorption spectra measure 9 standard samples with various mixing ratios and 3 verification samples with known mixture ratios for verification, and by using a few parameters.
Next, we will move to the second application, which is metamaterial-based sucrose detection sensor using UV-VIS-NIR Spectrophotometer. First, with the aid of a UV-VIS-NIR Spectrophotometer, a single negative metamaterial surface is created using the e-beam lithography process for use as an optical sensor over a wide wavelength range. The suggested metamaterial-based sensor has a greater detection accuracy and sensitivity than a simple thin film sensor, measuring sensitivity of 0.893 and 1748.8 respectively. So this application discusses optical sensing techniques that are commonly used, such as optical grating, thin films, interferometer, surface plasma resonant SPR, and localized surface plasma resonant LSPR. The weaknesses of optical sensor used in an open environment are emphasized, including the possibility of inaccurate reading. A new technique employing a closed environment of UV-VIS-NIR spectrophotometer is presented to address this problem. In comparison of other optical sensing techniques, this technology is said to have a higher sensitivity. Employing transmittance as the primary metric for sucral sensing, the study measured absorption and transmission in accordance with the Baird-Lambert law. The transmittance tips wavelength change is used to compute the proper sensor sensitivity. Next, a case of study. The study used a fabricated single negative metamaterial surface for sucrose sensing using a spectroscopy technique. The Shimadzu UV-3600 plus UV-VIS-NIR Spectrophotometer is utilized for thin gold film and metamaterial surface sensing. The bare silicon wafer is first utilized to calibrate the UV-VIS-NIR unit as a reference because silicon is the substrate used in the sensor chip. So the sensor chip, solution and reference are placed in the cuvette together for sensing after they have been set. So compared to a basic SPR sensor which is open environment, a spectrophotometer being a closed instrument offers an optimal and error-free sensing environment.
Finally, the ultra-low stray light, high sensitivity, high resolution and cutting edge of the Shimadzu UV-3600 spectrophotometer have been led the way in many approaches and researches. The extra attachments are compatible, huge and multifunctional sample chamber and integrated sphere attachment to measure the solid sample. It also the high precision, absolute spectacular reflectance measurement can be made using the ASR series. The measurement application can be used or handled using the microscopic cell holder and the thermoelectrically temperature control the cell holder. And compare the previous one, the Shimadzu UV-2700, Shimadzu UV-3600 has a broader wavelength range, and the new one outperformed the competitors in a number of areas. Thank you.